we see that how to calculate it, the Naive Bayes equations, and how to calculate the Naive Bayes equations. We have see that we have to calculate it, the likelihood to probabilities, as well as we have to classify here. So first write down what is actual the final equations we got in from our Naive Bayes equations. Suppose let's take we have interest to calculate it, the probability of class 1 for a given data point, for a given data set. So let's take our data sets. Data point is like that, w1, w2, w3 up to wd. Let's take. So this probability is what? This probability is the multiplications of two kind of probabilities. The first one is equals to, for classifier here, that is probability of y is equals to 1, and another ones are the likelihood probabilities, that is probability of the w1 for given class level 1, probability of or w2 for given class level y is equals to 1, similarly as well others one. So the last one here will be probability of wd for given class level y is equals to 1. Just as simple, we have seen this probability, we call that this probability or prior probability, prior. Okay, I think this if some you have misplaced something, so please correct it. And this kind of probability we call that the likelihood probability. Okay, I've seen these kind of things. So but the main problem is suppose let's take suppose let's take our d is equals to, let's take our d is equals to 100. Let's take, if g is simple, if d is large, then we have faced one problem, that is the numerical stability problem. So what is this problem actually? Numerical stability problem is actually, what is this? So just see this, actually at the end of this h is probability. So this, if this was a probability, this value is lies between 0 to 1, this value also lies between 0 to 1, h probability value is lies between 0 to 1, and this thing also, this value is also lies between 0 to 1, and as well this 0 to 1. So the problem is we are multiply the value, we are multiply such 100 values from between 0 to 1. Okay, we are simple we are multiply this 100 value from between 0 to 1. So the multiplications of the 0 to 1 value is also less than 0 to 1. Just see one example. Suppose let's see, suppose if we just interest to calculate, suppose let's say our first value is 0.2, second one is 0.1, third one is 0.2, and fourth one is simple. Here we are interested to take this 4 value, only this 4 value, but actually this in this probability we are calculated the hundreds of thousands of this kind of value. Okay, if we just simple multiply these 4 values, so actually what will be the value? So this value will be 0.0004. okay, just see how much small this one. So the main problem is, if we just multiply this such kind of 100 values, if we just multiply 100 numbers, if such 100 numbers between 0 to 1, okay, then what happen? Actually if this we multiply, so this value will be so small. Okay, this value will be so small. So we have faced one problem that is called the numerical stability problem. So in such cases, in such situation, we faced numerical stability problem. This problem is called the numerical stability. Faced numerical stability problem. So the numerical stability means in another language this thing is called the numerical underflow problem. So numerical underflow. We see what is this thing. Numerical underflow problem. So numerical underflow means if you just remember the Python library. If you, I think all of you are know about the Python language. So in Python you will see the double precision point. Just if you just call the double precision. So in double precision, in this double precisions, we have actually the we have rounding of the number, numerical number up to 16 significant places. Okay, up to 16 significant places. Values means that if you just taken some example of pi. Okay, if you examples the same, so pi will be 3.21 something dot 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 up to. So if you just using the double precisions, so after 3 point something, actually in Python they are have default setting in double precisions, they are have 16 value, they have taken only 16 value, only 16 digit, only 16 digits it has taken in Python in default settings. Okay, in precisions, for precisions purpose actually it is taken 16 digits. So if you just multiply the number, this kind of number that is less than 1, so up to hundreds time and thousands time, so you can assume how small this number will be. So how to get rid of from these situations, this is the main thing, how to get rid of 16 digit after rounding off. Okay, now the main problem, how to get rid of this situation. So this thing we are simple using the trick of logarithm. We will see the log is simply a monotonical increasing function. Just we will see first here we are actually using the log probability. Okay, simple. We are just by simple by the character of log. We have no. We have in 12th standard, 11th standard, we have no log of a into b is equals to what? Log of a plus log of b. Because of these characteristics, means simply our log probability convert these multiplications to a addition. This log convert the multiplication to addition. Because of this thing, we are simple get rid of. So because of this thing, we are simple instead of multiply here, we are using the compare the log probability. So you can see, sir, unless of log, there have many functions you can use. So let's see why we are using the log functions. Let's see one by one, step by step. Suppose what is our actual probability? Our probability is this one. Actually probability, just simply just write down this probability. So our probability is probability of y is equals to 1, w1 w2 is equals to our fire probability into I is equals to 1 to d. sorry, probability of y is equals to 1. This is the probability. Just I am simple here the logarithm function. Simple, I am using the log functions. So log of this probability will be what? Log of this probability now will be y for class 1. Now simple, I am using the log functions. Simple, we have seen that log multiplications, it converts to additions. So this thing will be log of plus this multiplication sign now will be converted to the addition sign. Of the given y class level y is equals to 1. I think this clear concept is clear, all of you. How it is now, how it is the advantage, why we have taking the log algorithm. Just now see there. Now just see it. So we have seen that actually we have to compare this probability. If we just consider the binary classifications, we have to compare this probability with class level 1 as well for the class level 0. If we have k class level, we have to compare such kind of case probability as other, and we have to choose the maximum probability. And we know that log is a monotonical increasing functions. Log of x is a monotonic function. Monotonic. Okay. Log is a monotonic functions. Because why? Because if we increase the value of x, then log of x value is increased. So if we simply using the log value, so just we are converting, if you just after taking the logarithm, then after if we just compare this thing, I think then the comparison will be the same thing. Because suppose if you just consider, just for a moment, if you consider this thing is x, this thing x, so if x value is increased, then total this value, then total log of x value will be increased, because log of is a monotonic function. So after final result, if we compare this thing and this thing will be same thing. If we compare x and instead of x, if we compare log of x, both are the same, they both the same, the result will be our same. Actually we have to compare. If we see that, if from suppose let's take we have three numbers x1, x2, x3. Okay, we are comparing between these three numbers. Suppose let's take our x2 is the larger one. Instead of comparison these three x's, if we compare log of x1, log of x2, log of x3, if we compare these three values, then what happen? So in this probability, in this log values, this one will be larger, because log is a monotonic function. Simple, because of this logic we can easily compare this thing. Okay, I think till now it is understand, all of you, it is understandable why this thing is important. Okay, so what we'll see, we see that we are comparing simple this thing log values. So just see here, now see this value. So here actually we have got this value. When we have gotten taking the multiplications value, we got this one, we got this value. When we are taking the multiplication simple, we are taking this value. So simple, instead of taking the multiplications, if we using the log functions here, so log of this value will be what? Log of 0.0004, it will be something minus 2.23979, something like that. Okay, so instead of just if you just round, if this number is so small, suppose after we are interested to multiplication such kind of 1000 numbers, so this value would be 0.000 up to 1000, after 1000 there will be some number. If we simply using the log functions here, so we can easily find some numerical value here. So from by using this thing, log functions here, we can easily get rid of from this problem. So because of this thing, we can easily use, because of this thing, mainly because of log of f to the a power b is equals to b into log a. We know this property of everyone will know. So simple, log what will do? Log what doing? Log in log. Log actually convert the multiplication thing. Log convert multiplication to the addition, and as well as log convert the exponential to the multiplications. Okay, I think these two things clear all of you why it is important. Okay, simple, because of this thing, because to get rid of this numerical stability issues, we are simple using the log functions. Okay. So just before finishing this lecture, I am just conclude one thing. So this technique, Naïve Bayes technique, is very old technique. Okay, and but till now we are just sitting on the edge of computer. We have sufficient amount of system that can easily calculated huge number of calculations. But if you just remember the early 90s, there have no any such kind of computational power. So in that age, they are using simple the logarithm function to calculate the huge kind of numerical values, such kind of numerical values. Oh, so okay, now we are in this age, we are using calculator, computers. So in that age, but in early 90s, early 1990s, okay, but early 1990s, they are simple using the log tables. The mathematicians, scientists, they are using simple the log tables to calculate the most complex value. So let's see an example how the logs table useful to calculate this value. Suppose we are interested to calculate it 2.2 to the power 3.6. We are interested to calculate this value. What will be this? And we have no any calculator or computer something else, and we can easily calculate this. How we will calculate this value? And but in previous we have the log tables. We have log tables. How to calculate it? Suppose let's take this value is a. Let this value is a. So just we are using the log in both sides. If we taking the log, so what will be this value? 3.6 into log of 2.2. And by simple using the log table, we can easily find this value. We can easily find by simple using the log tables, we can easily find this value. And now suppose let's take, after seeing this log table value, suppose let's take each something from log table we got, and after multiplication we get this value is equals to a. Okay, we get this value is equals to a. And now how we'll calculate, and also we have log table as well as also we have anti-log table. There are two types of tables, log table as well as anti-log table. So simple, from this log table we are calculated this value, and now we have to interest to omit these functions. How to get rid of? We are simple using the anti-log of log of 2.2 to the power 6. So anti-log and log both are cancel out each other. So here log of a cancel each other. So 2.2, now the value will be 2.2 plus 3.6 will be anti-log table. Well, let's see. So this value easily we can find from the anti-log table. in this, by using this type of concept, so in early 1990s the scientists, mathematicians calculated this kind of complex value. Okay, so I think this lecture is all about clear how the log probability, why the improbability, the scientist, mathematician taking the logarithm value. Okay, because of the simple numerical stability issues. Okay, and I think how you will see how beautiful this log function is. Okay, I think every calculations and everything concept till now, how about the Naïve Bayes theorem, it is all about clear. But up to this lecture, if you had any problem, please comment below, then I will try in my best to give my solutions. Okay.